this is a 90-minute session. And you shouldn't have the expectation in any of our sessions that you're going to master everything during the session. We cover a lot of ground, and it can get kind of complicated. And so the point of these sessions is take away what you can from them. If you learn one or two things, that's great. But don't expect to understand every single thing we cover in the 90 minutes. That's where review and the recordings and going back over the handouts all come into play. And then attending the sessions again repeatedly, which I know many of you have been doing. So give me a Y in chat if that makes sense, letter Y. That you shouldn't expect to get everything tonight. Now the other thing is Algebra 2, this particular session is one of our most advanced. So if you haven't yet familiarized yourself with what's in the Algebra 1 session and the number sessions, the number properties sessions, you may find this that goes over your head. I can't say for sure, but you really want to understand what's in Algebra 1 before you try to do Algebra 2. So if you find that this is just getting past you, that's okay. You could stick around anyway, or if you find it's too much for you, you can leave. Yeah, last night, Candida, exactly. So there was an Algebra 1 just last night. But in any case, that's really a necessary foundation for what we cover here. So let's jump in. Here are our goals for the evening. Okay, so let's start with a polynomial and what it means. Polynomial just means many numbers, polynomial. So it's an expression that contains multiple different algebraic terms. I'll give you an example here. So here I have 3x squared plus 7y plus 8. Now this has three different terms in it. We have coefficients, we have variables, we have, in this case, exponents, and then we have constants. And you want to know what all of these different things mean. So coefficients, first of all, are the numbers you are multiplying variables by. Variables are the letters, x and y in this case. Those coefficients tell us what we are multiplying those variables by. So 3 next to the x squared means we're multiplying x squared times 3. 7y means we're multiplying y times 7. The variables, you may know, are the letters. Now let me make it clear. Variables are unknown values, but they're real values. They actually have values. We just don't know what they are. So we're given them as letters, but they have a real value. Then we have an exponent here. Some of you might know this as a power. And in this case, we're saying x squared, which means x times itself once, x times x. And then we have our constant. The constant is just whatever number is added or subtracted at the end of the expression. In other words, that has a constant value. It doesn't change. It's just 8 plus 8. So you want to understand these different vocabulary words, what they mean. Oh, thank you, Boris. If you need the PDF, Boris just threw it into the chat. Please be sure you have it. By the way, if you ever feel the need to grab screenshots in here, that can also be very helpful. All right. Now, if a polynomial has two terms, we call it a binomial. Binomial literally just means two numbers. So for example, x plus 7, remember x is some number, we don't know what it is, and then 7, that's our other number. Y minus 4, same deal. Y is a number and Minus 4 is another number. Now, when you add or subtract polynomials, you can only add or subtract what we call like terms. Like terms have both the same variable and the same exponent. So for example, here we have 8 times x squared, and here we have negative 6 times x squared. Since these are both x squared, same variable, same exponent, we can combine them. It's like if you have 8 chicken eggs, and then you subtract 6 chicken eggs, how many chicken eggs will you have left? These are all chicken eggs, called x squared. That's right, Doc Shesh, very good. We're subtracting. Yeah, Olivine, very nice. Now here we have 9 times y squared, so those are duck eggs, and then 9 times y to the 4th. Those are like, I don't know, ostrich eggs. We can't combine those. Those are different kinds of eggs. Y squared is a different kind of egg from y to the 4th. So we're just stuck with that. There's no way to combine those. No, Safin, we can't do that. We can't do that. So these are just different from each other. They're unlike terms. Okay. Now, if they are like terms, we just deal with the coefficients. In other words, we add or subtract coefficients. And remember, we're only talking about addition and subtraction at this point, not multiplication or division. We'll get to that. So 8x squared, 8 chicken eggs minus 6 chicken eggs is 2 chicken eggs. Folks, give me a Y in chat if you get that point I'm making about chicken eggs. They're all the same thing. Yeah, x squared, 8 of them and negative 6 of them. That's it. They're all one kind of thing. These are different kinds of eggs because of these different exponents. Okay. Now you can divide polynomials by one, what we call monomial, one term. So here we have 4x squared, so that's one kind of term, minus 8y cubed, that's a whole different kind of egg, right? But we're dividing both of these by 2. So we can divide 4 by 2, and then we can divide the 8, or technically it's negative 8, by 2 to simplify. And I can separate those two pieces out on the top. So this is the same as 4x squared divided by 2 minus 8y cubed divided by 2. So see if you can tell me in bars what 4x squared divided by 2 would be. What do you think 4x squared divided by 2 would be? You're thinking multiplication. This is division. Yeah, it's 2. It becomes 2x squared. And negative 8y squared, I can just call this 8y squared. We're subtracting it. Somebody asked if minusing, if the negative sign up here is the same as minusing, and it is. So 8 divided by 2 is how much? Yeah, 4y cubed, Miguel, or negative 4y cubed to be specific. Very good. So in other words, 4 divided by 2 becomes 2 for the x squared. 8 divided by 2 becomes 4 for the y cubed. And you notice the exponents and the x's, and the variables rather, don't change. They're the same. You could put it this way, and I hope I'm not overcomplicating here things by saying this. We're multiplying the top by 4, and at the same time, we're dividing by 2. That may seem like a silly thing to do, but that's really what's going on here. Here we're multiplying by 8, but also dividing by 2. And you just want to understand that concept. So in the end, 4 divided by 2 is 2, 8 divided by 2 is 4. Okay. Yeah, so you do it in that order. You want to do it in an organized, systematic way. All right. No, it is a fraction, Ashley. Fractions are division. This is absolute. These are fractions. This is a fraction. Fraction literally means dividing. Yeah. By the way, if you do have questions here, folks, for those of you who've been to these sessions before, where should you ask your questions? I should have said this at the beginning, and I didn't. Yeah, Q&A. You got a separate Q&A chat. Boris is an expert, and he loves to answer your questions. So if you put them in Q&A, you can ask the question privately and get an answer, and that way we don't kind of lose momentum, and also your questions don't just like disappear in the chat and I don't even notice them. Okay. Now you can also divide by a variable underneath. So it doesn't have to be a number, it could be a variable. So here I'm dividing, in this case, 4x squared minus 8y cubed by x. Now, x squared, remember, that really means x times x. So I'm dividing x times x by x. So in other words, here we can think of this as x times x. I'll actually write that here, re-express it as x times x. So on top here we have 4 times the quantity x times x. That's what x squared means. And underneath, I'm dividing by 1x. We normally wouldn't put a 1 in front of that. That's just to show us that there's only 1x. That's what this means. So if I divide x times x by x, Abraham, exactly. Miguel, that's right. One of the x's cancels on the top and the bottom. We're dividing out one of those x's. So we end up with just 4x here. Excellent. Now here, these are different kinds of eggs, right? Y cubed and x, I can't do anything with that. I can't simplify that any further. So in the end, this becomes 4x minus 8y cubed over x. I can't simplify the second fraction any further. Yeah, different variables, D. Exactly. Can't do more with that. Okay, give me a y if you think this is clicking for you. And of course, if it's not, Boris is here for you. And again, you don't have to feel like it's all coming to you at once. This takes practice. It takes repetition. Nobody learns this in 1 hour or an hour and a half. Okay. Here's another fact to be aware of. There is no way to divide something by 0. And the GED might test that concept. Dividing by 0, we say, is undefined, because you can't do it. You can't divide something by nothing, in effect. So if you ever see 0 underneath a fraction, it's undefined. It doesn't have a value. All right. Now, sometimes they'll give you fairly complicated polynomial division. In other words, these fraction situations, where you have complicated polynomials on both the top and the bottom. And what you want to do in those situations is see which factors you can divide, like numbers, We saw 4 divided by 2 earlier, or 8 divided by 2, and also which variables there are in common on the top and bottom. So you can see this gets a little bit more complicated now. Now we can still do that process of separating out our two top terms. So I can turn this into 8x to the 4th power times y over 6x squared times y, plus another fraction, 6x squared times y cubed over 6x squared times y. So you see the denominator, the bottom of the fraction, stays the same. And I've just separated out the top. Madam Lee, we're glad you made it. Okay, so now I can start simplifying these piece by piece. So I've got my coefficients, 8 over 6. I've got x to the 4th divided by x squared. And then I've got y divided by y. And then here, 6 divided by 6, x squared divided by x squared, y cubed divided by y. And again, I have to look to the common variables or numbers to see what I can do. So 8 over 6 becomes 4 over 3. I'm basically just dividing both the 8 and the 6 by 2 to turn them into 4 and 3. And then 6 over 6 is just the same as 1. And then from there, I can start dealing with the variables. So let me deal with that now. See if you can tell me in Boris, what's x to the 4th over x squared? X to the 4th over x squared. Right. I agreed exactly. Very nice. X cubed. Sorry, x squared, not x cubed, x squared. So in other words, we cancel out the top and the bottom. So we're left with effectively with just 2 x's on the top, x times x on the top. And you can see here, because we have the same value top and bottom, x squared divided by x squared, they just cancel out. Dividing something by itself just means it's 1. And now we'll go on to the y's. Deal with the y's. I have y over y, y divided by y. Same theory as I just said with x, or with x squared over x squared, y over y is nothing. It's 1. It's just 1. It's not nothing. It's 1. So now that cancels. And then y cubed over y. Remember, that means y times y times y on top over y on the bottom. So one of the y's disappears. And we're left with 2 y's on top. Now 1 and 1 here, I can basically ignore those now, forget about them. And this 1 here just means it's y squared. So I can simplify that at sort of another step. And this is our final simplification. Okay. Now I want to just sort of leave this up for a moment and let you just sort of digest it. Because there's a lot going on here. We did a lot of steps. And let us know, of course, what questions you have about any of these steps. And try to be as specific as possible with your questions. When you ask Boris something, say, hey, Boris, I didn't understand how x to the 4th over x squared became just x squared, or whatever, or how y over y became 1. Be very specific so Boris knows what to address. If you just say, I don't understand, that doesn't help Boris. He doesn't know what to clarify for you. Okay. I see a couple questions coming in. Let me just take a quick look at them. So someone's asking a great general question. This is my first class. I missed last night's class. How do I get access? On your account, you have recorded versions of every class. So it's not actually last night's class, but it's a recorded version of Algebra 1, the whole session. You have recordings of every session on your online account. And actually we generally recommend you watch those recordings like multiple times after you've attended the class to really let all this stuff sink in. And then you also have PDFs available on your library for all of these sessions. Let me just see what the question is. Zaire, you're saying have it 8x to the fourth turn in 8x to the fourth turn into 3x. It didn't turn into 3x to the 4y. So let me just be clear. 8 over 6 here is the same as 4 over 3. I'm just dividing both the top and the bottom by 2 to simplify 8 over 6. That's the same as 4 over 3. Good. Okay. Okay. All right. So again, if you have further questions, please let Boris know. I don't want to get too far behind Leah, so I don't want to go over the whole thing again. But again, I urge you to just, like watch the recording in a day or two, or even tonight if you want. And it'll sink in. Again, I want to reemphasize, this is a lot of stuff we're throwing at you. Now, if you haven't seen Algebra 1 yet, that might be part of the problem. And also, our basic math sessions, number sense part 1 and number sense part 2, those are important also as foundational skills. All right. So what we're going to do now is we're going to start doing some example questions for you to practice on. Give them a shot. I'll put up a poll for you. Please don't put spoilers in the chat, by the way. If you come up with an answer in the poll. And I'll give you some time on these. I won't rush you. And then what we'll do is after each question, after you've had time to answer, we'll go back over them together.